The best and brightest world engineers and entrepreneurs focus on developing renewable energy like wind and solar, a lesser-known concept. Anaerobic digestion is emerging as the next big green sustainable opportunity. Capturing energy from organic waste is regarded as one of the most dominant future fuel sources because it can provide continuous power generation through an abundant and economical feedstock, our own trash. Anaerobic digestion is a true closed-loop system where food waste is produced by a community, converted into electricity, and sent back to the community as power or nutrients. Okay, so I'd like to start with the problems, the reason that we need anaerobic digestion. First, it's an alternative fuel source, so it decreases our dependence on fossil fuels like coal.
Second,
Anaerobic digestion produces a byproduct, a solid digestate, that is a nutrient-filled fertilizer that replenishes soil.
third,
Anaerobic digestion produces a second byproduct, a nutrient-filled gray water that can be used for fertilization. Fourth, during the process of anaerobic digestion, methane, which would have been released during the landfill process, is captured. Methane is a terrible greenhouse gas which stays in our atmosphere even longer than carbon.
lastly,
We have limited landfill space.
limited, very limited, very limited.
Organic food and yard material make up 25% of our landfill space. Diverting this material saves valuable landfill space and reduces municipal disposable cost.
Personal interest.
In 1984, my grandfather, Gordon Dancy, invented the first high-density plastic grocery bag. Later in 2008, my mother, Kristen, invented a reusable bag in effort to undo my grandfather's wrong.
Trying to save the sea turtles.
Because of this, my mother has been an active environmentalist my entire life, and I grew up in a zero-waste household. I've been taught how to properly compost, recycle, reduce, and find creative alternatives for reusing all household materials. With my interest in learning how to compost, I became interested in anaerobic digestion, which is another form of composting. The main question is, what is anaerobic digestion?
Well, good thing you might ask.
The engineering and biological processes can be seen in the three main components of anaerobic digestion.
Gathering the needed feedstock, digesting the waste anaerobically, and deploying the products obtained from the digestion process.
First, let's talk about the biomaterials. A critical part of the anaerobic digestion process are the materials that are needed for the optimal mixture. These materials are the scraps left on your plate, the sewage and sludge in your toilets, farm animal manure, and even your dog's poop. Essentially, the shit that no one else really wants. Are the organic materials to create an optimal mixture. Now let's talk about the biological processes. The technology itself is rather simple. It is a natural way of recycling organic waste into fuel. The collected waste material passes through a series of screens so that the pieces of inorganic trash and plastic metals can be separated from the organic material. The remaining concoction is blended into a liquid and enclosed in oxygen-free storage tanks. Because the process is anaerobic, it's important that the tank is oxygen-free in order for the digestion process to occur. Once inside the digestion tank, the mixture is heated to about 100 degrees. The process is fueled by friendly anaerobic bacteria, which survive and thrive due to the lack of oxygen and high temperature within the tank. Over time, the oxygen-free environment allows for the naturally occurring friendly anaerobic bacteria to separate the material. The materials remain in the digester for about 30 days, so that the three biological processes can transpire to digest and break down the mixture. Biomass destruction, a breakdown of solids, nurification and transformation of ammonium into nitrate, and the denitration, removal of nitrate compounds. When these three occur at the same time, it is known as anaerobic digestion, ultimately releasing oxygen, water, methane, and a dark slurry of organic material and nutrients called digestate.
Little dance break. Do you want to practice a couple more times?
Let's talk about the products of anaerobic digestion. The byproducts of digestion can provide vital resources to the local region. The methane-rich gas is siphoned off and refined into energy, or biogas, which is used for fuel in turbines. The energy can be used to power local buildings and even power the digester itself. The biogas can be used to power cars, buses, or anything you can imagine. The digestate, which is a solid material, remains after the anaerobic digestion process. It is full of nutrients and can be used as fertilizers for farms or as a replacement for phosphorus, which is a non-renewable. Lastly, the water that is produced is clean and sent back to the sewer system, promoting water conversion. There are several benefits of anaerobic digestion. One of the major benefits of anaerobic digestion is that it provides multiple cost-saving opportunities for local communities. First, the waste stock is diverted from landfills to the digester at a lower cost, creating savings on waste disposal bills.
Second,
Power from the digester is generally purchased for less than traditional power of gas.
lastly,
The fertilizer can be used at a lower cost, locally and financially. The water can be reduced in local systems, converting water from regional sources. The benefits and impacts of this bioengineering process are so very important to ecological and societal life. I have interviewed people from Hawaii to the east coast of South Carolina and asked, is anaerobic digestion a great reason to quit school and volunteer supporting this bioengineering process for the remaining years of your life? Here are the results.
Yes.
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 Yes!
Yes.
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 Oh, didn't see there. Yes.
Yes.
Yes.